Hello, today I'll be talking about coordination compounds. Let me start off by telling about Albert Werner. Albert Werner was the person who introduced the concept of coordination complexes. He won the Nobel Prize in 1913 for his research in linking of ligands. Now metals. What are metals? Metals can also be called as Lewis acids, as cations, as electron deficients, or electrophiles. For example, nickel, cobalt, iron, platinum, etc. Metals basically accept a pair of ligands. Now, what are ligands? Ligands are lone pair of electrons or electron-rich or Lewis base, that is like the opposite of metals, and these are nucleophilic, right? And any species of ligands have at least one lone pair of electron. So basically, what the ligand does is it donates its electron to the metal, and then the metal forms a pair with it. Now, ligands are of two types again, that are of three types, that are unidentate, bidentate, and polydentate. Unidentates are when the metal combines with one ligand. Di is when it combines with two ligands, and poly is when it combines with many ligands. Moving on to the coordination number. Now, number is nothing but the number of ligands that are combined with a single metal. There are about 1 to 12 ligands. Such. Now, if it's combined with, let's say, one metal is combined with two ligands, its coordination number will be 2. If it's combined with 4, its coordination number will be 4. Moving on to the structures. So these are basically the structures of the crystal field theory. Now, we all know there are two energy levels, that are T2G and EG. So we have different structures that the ligands are forming with the metal. Some are on the axial, while some are between the axial. So these are the six structures that it forms. The five structures that it forms. The first two are the structures for the EG energy level, while the last three are the structures for the T2G energy level. Coming on to the crystal field theory. Crystal field theory is basically a theory that talks about the energy levels that's formed by the coordination complexes. Now, it has one assumption. It assumes that the ligands are point charges. This is the basic assumption that we take whenever we are talking about the crystal field theory or the CFT. Now, what does it talk about? So basically, it tells us that there is a transition metal. Whenever we talk about coordination compounds, we usually tell about transition metals, like I told you, Fe and platinum, etc. So, like, there's a transition metal that is surrounded by ligands, right? So, like I told you, metals are electron deficient, so they attract the lone pairs of the ligand and get attached and make form a complex out of it. Now, transition metals are basically cations, since I told you they are positively charged because they are electron deficient, so the negative charge is less, which makes it positive. So they are cations. So the transition metal cations is basically surrounded by the ligands, lone pair, that is negative. Now the ligands are also of the ligand that is a point charge are maybe of two types, that is ionic or neutral. Now ionic can become all the negative charge ligands such as F minus, Cl minus, or Cn minus, or NO2 minus, any of these. And then the neutral ones that are neither positive nor negative, like H2O or ammonia. Now, the attraction. So basically, it is said that the attraction between the ligand and the metal that is formed is going to be purely ionic. Then, also one thing that we learned from CFT is that we can find out the metallic properties of the compound. That is, like I'll be telling you in the later video when I talk about the splitting of the d orbital in the octahedral and tetrahedral complexes. In that, I'll show you with demonstration how the metallic properties is formed. But in theory, basically when there is a lone pair after in the d orbital, when we fit the atoms, that is the valency or electrons. So then, if there is a lone pair or a not bonded electron, then it's paramagnetic. Whereas if there is like no lone pair, it's going to be ferromagnetic. Sorry, my bad. Diamagnetic, not ferromagnetic. Diamagnetic. And the Eg is basically the higher energy level, and T2G is the lower energy level. So that is it for this video. I'll be telling you about more of the CFT configurations and the d orbital splitting in the next video. Thank you.